Hello YouTube, RJ. Hey, got a couple more Chinese packages on the bench. Gonna open them up. I think one of them is a radio kit we're gonna build today. If that's what one of these is, we have to find out here first. So let's crack these things open and see what we got in them. I saw this little R10 radio receiver kit on AliExpress, and I just wondered how good it actually could possibly work. So I purchased it with that in mind. And I don't know if this is it. I think one of these is it. I'm not positive though. This is it. This is they call it the R10 Shortwave Band AM receiver. It's a bag of parts, absolutely no instructions with it. Just a circuit board and a whole bunch of parts put together. Nothing's marked. I knew that. I downloaded the instruction manual. I hunted online and found this. That's what we're going to do today. Let's see what we got in this other box first though. You know, I don't need it. I just looked at it and thought, you know, how good could that actually work? Decided to order one. Figured we could put it together and find out. It's just be fun to assemble and see how it works. This feels like it's got a couple things in it. Oh, I think I know what these are. Yes. Transformers. And I think this is probably the same thing, isn't it? Yes, 2 transformers. And this is for a project that's coming up. This is a potential part for a potential project that's coming up. These are high frequency for like switch mode power supply. So I picked a couple of them up inexpensively, and we'll check them out later if it looks like they're going to work out in our project. So let's get back to the project at hand, which is our bag of parts receiver. So now there's no way I'm going to make you sit here and watch me build this whole kit, as you can imagine. So here's what we're going to do. I'm going to do certain parts of it on cam, and then do the redundant things off cam. Or in some cases, I'll just do time lapse and run through very, very quickly, you know, a few thousand times normal speed, and we'll go from there. Now I can tell you a lot of time is going to be spent figuring out what parts are what, because I mean all the resistors are just lumped together. I mean this is literally a bag of parts, and that resistor right there was doing its best to get away. What I got here is just a ton of parts. You know, not going to be the easiest kit build I've ever done, being that parts aren't labeled or anything, but we'll sort things out into what they are and kind of get things sorted here just a little bit. 2 circuit boards, one with a bunch of surface mount already on it, and some chips we hope are good. And this board pretty well looks complete. I don't really see, looks like all we have to do is put the connector and maybe the rotary encoder and the LED on it to complete it. See if the silk screen helps us out much here. It's got enough markings to get by if the instructions are halfway reasonable. So let me organize some of these parts out. I'll go ahead and probably test a few, make sure the transistors and stuff are good, because I have read that when you buy these thrown together Chinese kits like this, sometimes the parts you get are swept up off the floor and they're not even any good. So before you pull your hair out, sometimes it's best to go through and check them all. So I'll run through and check parts, kind of sort them out into capacitors and resistors and stuff, and kind of get things a little organized, and I'll come back and we'll pick up from there and we'll get this built. So see you in a few. Okay, we're back. Took me quite a while, spent probably over an hour going through and sorting the parts. What I had to do was with the resistors, every one of them I had to check and then create a bag for, mark up and separate. They were just, of course, all blobbed together. The ceramics for capacitors were the biggest pain because many of them aren't even marked. So I had to go through and sort those. I've got everything. The capacitors, the ceramics, I have a couple extras, like one extra of a couple sizes. Went through the parts list, checked it all off, made sure I have everything. We've got everything. We're looking good. You know, I was afraid that being that it's a hand sorted kit, probably we'd be missing things, but it's looking good. We're ready to set up and start building this rascal. So I'm going to kind of take a quick glance ahead at the instructions, make sure I have a grasp of what I'm doing. And I'll come back and we'll get started on building this thing. It's always good to brief through and read a little bit of the instructions and be ahead on the instructions, because you know, instructions have a habit of telling you to do this, do that. Oh, but only after you've done this and that. You know, these kind of things where if you don't read ahead, you sometimes put yourself in a jam. Not much in the way of instructions in this, by the way. It's more, we've got a schematic, we've got a layout of the board, and just a page of instruction. So I'll read through this one page of instruction, come back, and we'll get started. So, okay, well, wasn't much to that. That one page basically talks about markings on components, which way is which on a diode, that kind of thing. Really no assembly instructions at all. So all you really have is an image of the circuit board with the component markings for C3, C4, and a bunch of parts. It's up to you to figure it out. So it's going to be a little slow, because what that means is you're going to end up having to refer back to list of components and getting their reference designated numbers. Like in the case of the 100 ohm resistor, it's R1, R8, R13, and R16. So what we got to do is we've got to pull those resistors out, make a note of those, go find those, and put them in those places. So that's all there is. It's just going to be a back and forth. But hey, it's a Chinese cheap radio kit. You know, what did we expect going into this? I didn't expect any better. Did you expect any better? I didn't think so. So let's get to it. I think what I'm going to do is I think I'm going to pull the parts list sheets out of my book here. And that way I can have the diagram right there in front of me while looking at which items are which. So let's just do that. Okay. So why don't we start out with the very first components. You always want to stay with the small items. I'm sure you know that if you've ever done any of this. But if there's any viewers that are new to electronic stuff, always try to do your smallest, shortest items. That way, if you need to flip the board over to solder, you're not being held up so the part tends to fall through and makes it harder on you. It's just a lot easier working that way. It's much easier to work with your shorter items and work your way up to the taller items. So let's start out with resistors. They're going to be about the flattest item that we can have on this board. So we'll start out, what we'll do is we'll start right down the parts list, and the first part item is the 100 ohm resistors. Let me go find my 100 ohm resistor bag here. There it is. What do we got? 4 of those. So we got 4 of these to put in. Yep, R1, R8, R13, R16. So what we'll do is we'll dump them out, and we'll start locating these locations on the diagram here and putting them through. And what I like to do is I don't like put one through, solder it, put another. I just go put these things through, flip it over, solder all of them, trim them off, move on. Little more efficient. So I'm looking for R1. So we're going to start on here. R1's right at the top of the board here. Basically, we're going to bend these leads in. Get R1 in place. Let's see what they're doing. Okay, the interesting marking that they're doing on this kit is they're putting a circle around one of their pads. Maybe you can see that, hopefully, here where I'm showing them. I'll get it over maybe a little better. They're putting circles, and what they're telling you is they want the resistor body. So these resistors are going to be standing up. They're not going to be laying flat on the board. Sometimes they do that to save space on a board, to make a board smaller. So when you do that, you take your resistor and you bend one lead over, down itself like this, and then we're going to go in and drop R1 in like this. So the circle's telling me where the body of the resistor, they want the body of the resistor to be. So there's R1. Let's find R8. R8 down here at the near the bottom of the board, just above the terminal strip right here. So here's R8. R13. R13's right here. And the last one's R16. R7, R16's right here. And see, this one, they're not wanting you to stand up. You're laying her flat down on R16. So that's when you bend both leads down and put it in. Okay, so we've got our 100 ohm resistors in. We're ready to solder. Let me get set up, grab my tools I'll need to solder with out. Go ahead and fire up my soldering iron. Get her warmed up. And I'm going to go ahead and set up the fume hood so that I can use it as needed. Okay, and give me some solder. Reach over here, and we should be ready to roll. So let's do a little soldering. Okay, now those solder, let's go ahead and clip them flush while we're here. And there we go. So here's what we're going to do. I'm going to go ahead and do the rest of these resistors, but I'm going to hold off on recording all of it. I don't think you guys want to sit and watch me repeat this over and over for each of the resistors. So I'm going to go ahead and get those loaded up. I'll come back when we're ready to change over, go to the capacitors and such, so we can take a look at what we need to know about putting the capacitors in. So I'll be right back. All right, we're back, and I've got all of the resistors on the board. Pretty straightforward. You do have to stand the resistors up in most cases. There's a few of them that lay down, but nothing tricky there once we sorted the resistors out. That was the hardest part, was getting everything sorted out. So now we're ready to move on, and I would say the next thing to do, in my opinion, is probably put these capacitors in, all the ceramic capacitors. I'd hold off on the electrolytic capacitors until later, as they're taller. I've got them all bagged up in order, and so it's just going to be a repeat of the resistors. Basically find them on the parts bin by the size and then which one of the designations for that size, put them all in, and then of course soldering them in. Won't make you go through the whole thing. Might actually time lapse it just for something to watch. If you don't care for that, just bump through it, jump over. I'd like to get some feedback. If people want to tell me what they'd like to see me do in these situations where I'm doing these tedious over and over things, you know, do you like the time lapse? Do you like me just to cut the video? You tell me. You know, this video is being made for you, not for me. I could do this without video in it. You let me know. Give me some comments. Reach out and let me know what you prefer. If I can get a consensus, then obviously that's how we'll handle it. So for this one, I'll probably go ahead and just do a time lapse. So enjoy. Okay, with that, we've got our disc capacitors all put on. We're ready to keep moving. The big question, the most important question I have for you is, did you catch it? Were you watching? Did you catch it? If you were paying close attention, you caught me make a mistake. If you were paying real good attention, you caught me make 2 mistakes. Did you catch them? Everybody makes mistakes. Always look your work over. Always think about what you're doing. It's very easy to do things like not pay attention and grab the 0.01 microfarad instead of the 0.1 microfarad capacitors. Good thing that they're a different counter. I'd have been farther down the road before I figured out I had the wrong ones in. These things happen. We all make mistakes. My promise to you is always show you my mistakes. I don't hide from them. I make mistakes like everybody. I probably make more than you do. But, you know, if you want to learn, you have to make mistakes. Can't learn from everything going right for you. You have to have mistakes once in a while to learn. And for you to learn, you have to see my mistakes. These are the things you watch out for. And I want you all to know we all make mistakes. Because if I do this perfect video, and could I edit all that out? Absolutely. I could make it look like this was flawless. I didn't make any mistake at all. The problem is, then it leads you to believe that anyone that's even reasonably good at doing this doesn't make mistakes. When you make a mistake, then you feel like, hey, this isn't for me. I make too many mistakes. And I say, nay, nay. We all make mistakes. You don't always see everyone's mistakes, but we make them. Even people who have done this for most of their lives. So, in fact, probably we make more mistakes because we're a little bit relaxed. We've done this, we've seen it, we've done it all. So we probably make more mistakes than the newbie because the newbie is really paying attention. They're trying to grasp what's going on. So just watch me make mistakes, you'll learn from them. That's a good thing. I'd rather make the mistake and let you learn from it than have you make the mistake and get frustrated and give up. Got that done, big milestone. Now, I haven't really told you all what we're going to do in this video. We're going to build this thing. But what we're going to do is we're going to build it, get it built. And then because this video is going to be plenty long enough, I'm going to turn around and I'm going to do another video, follow-up video, where we actually hook this thing up, test it, put it through its paces, and see just how good it is. We'll do a little comparison. We'll tune into shortwave broadcast. We'll hear what it sounds like on this. And maybe I'll fire up the old ham radio and we'll see what it sounds like on a high-end receiver. So kind of a neat ability to see how good a receiver this is compared to something designed to be very sensitive. So with that, we need to move on and put some additional stuff in. Let's make a decision on what we're going to put in. So I'm going to move this up a little. I'm going to bring some parts over here and let's talk about what would we put in next. Okay. Being that there's no instructions telling us what to do, all we have is a bag of parts. Let's take a look here and see that we have a lot of really tall things. We don't want to do the really tall things. So what's the shortest things we have? Well, we're getting down there to where probably about the shortest things we have are the sockets for the chips. Looking here, I think that's about the next shortest thing we're going to be putting on. We do have an LED, but that's not a big deal. We'll wait for that. So let's go ahead and put our sockets in. And this is going to be easy enough because we can see. Now, one problem is, I don't know if you can make this out here or not, but one of the pins are bent. And that's the problem with bago part kits. When they throw everything together, you can get that. So you just might have to be paying a little bit of attention. And if you're kind of new to it, if you look on the silk screen of the board, and you can see it here probably better, there's a little indent here. And there's a little indent in the socket, and that is pin 1 will be this pin here. So the socket goes in this direction. You'll also notice on the diagram there's a square pad. There's a square pad here too, and that denotes pin 1. So we want to get our stuff in the right way, because once we put this socket in, we might not be able to see the silk screen. And so the socket needs to tell me which way the chip goes in. So I need that notch pointing in the right direction. So you always want to check for that. And I know many of you are beyond this and you know these things, but we have viewers that might not. And so I want to make sure to go over that. One of the challenges with sockets is they don't like to stay in. And there's a lot of ways to get around this. One that people have used for many years is tape, and that works. Other trick that I do often, and I'm going to do it in this case, I'm going to bring my solder out here and kind of stand her up like that. I'm going to take my solder iron. Okay, so I'm going to get a little solder on here. I'm not going to turn the fan on because I need to talk. But I'm going to take one of the pads and I'm just going to place this solder on. Now you need to understand that solder is not good. You don't want to rely on that joint because you cooked, when you did this, that smoke you see is not lead or tin from the solder. That's flux burning off and cooking off. So when I did that, there was no flux to clean that joint. So we don't know that joint's any good at all. So we're going to redo that joint when the time is right. But for now, that's going to hold it in there. Okay? I'm going to do the same thing with these. Now, if you prefer to use tape, whatever works for you. I've seen people use, can't think of the name, rhodium, I think it's called. It's basically watch repair people's Play-Doh. And then I'm going to go around and tack a couple good joints in, and then I'll immediately go back to the joint. What I do is that I go opposite where I put the joint to hold it. The one pin I soldered to hold with the bad solder joint. What I'm going to do is go to the other diagonal, get a couple pins tacked in good on that side, and then I will immediately go back and hit the joint again with some fresh solder and flux to get it to make a good joint, make sure that I don't have a bad joint. So you can see I've got one pin on each of those joints pulled up tight, and what I'm going to do is, here's the one for this one, make sure you can see it. This one here is tacked. I'm going to go over here diagonally, and I'm going to solder this one. Now it's got flux in the solder, so we're going to get a good joint. And I might go over here and maybe do this one. I might come over here and do this one. And then I'm going to redo this one now that those are holding good. A little bit of fresh solder, a little bit of flux, there you go. Now I can run along and solder all of these. And I'm just going to repeat this on all of them. So I'll go ahead and run through real quick for you and let you watch me do this in high speed. Okay, and with that, our IC sockets are in. We've got them pointed the right way. We're ready to roll. What are we going to put in next? Well, we have to make that decision. Let's see what we got here. We got a diode. We probably ought to put that in. That's pretty short. I should have done that one probably already. The 1N4001 diode is D1. Let's find D1 in here. It's right up here. You've got a line with a triangle pointed at the lines. So just remember where the little line is on the side that the triangle is pointing to. That's where your line goes. You can think of it as the plus side, but we're going to stand her up just a little bit. So there we are. Get him in. Let's do a quick solder joint on that. You can always tell which side is connected to the negative ground plane because it's the one that takes longer to solder. It sucks the heat away. We've got 3 transistors to put in. We can do. Let's make sure we get the right one in the right place. One of them is a J310. I believe that's what I'm looking at here. But with my old tired eyes, let's be safe. Let's get microscope out here and take a look at what I got in my hand. Yep, this is the 310, so this is the oddball. If we look on here, we see Q3 is our 310. The little silk screen has a flat spot and a round spot. Well, the package, if you can make it out, is exactly the same. It is flat on this side and rounded on that side, so it's going to go in just like this. And you know, before we do, let's test that and make sure it's good. It doesn't take but a minute. We get this thing done and it doesn't work. We're going to drive ourselves crazy trying to figure it out. I mean, it might be interesting to do. I don't know that we'll drive ourselves crazy, but you know, if we find a problem now, we're going to be happy that we didn't find it later. So let's take a look at this and see what it tests out as. Says it's a N-channel JFET. Everything about it looks good, looks to me correct. So I'm going to say she's good. So we're going to put J3 in. If you're new to electronics, doing this stuff, you'll find there's a standard of Q tends to be transistors. Okay, R is resistor, C is capacitor. Everything tends to have a letter. L is typically inductor. Again, I know most of, if not pretty well all of you know that, but if we've got new viewers on, these little tidbits are helpful to them. We all have to learn this, and sometimes somebody just telling you before you get heavy into it makes things go a little easier. Okay, let's check this. What are these? These are 2N222 bijunction transistor NPN. Looks good. Let's check this one. This one checks good too. Looks about the same. I'm happy. So let's get them in. Put in Q1 and Q2. Those transistors are in. Let's see, we have a ceramic resonator here. It's fairly short that needs to go in, and its location is, hello, there he is right here. So right here on the board, the 3 holes right there with the oval around them. And we need to take a look at this thing. There's probably a number 1 pin. So I'm going to get under the microscope and take a look, see what I see. There's a red dot up here I'm going to assume is the number 1, which would be the square hole. So I'm going to put it in. And those are the kind of things starting out you sometimes might not know on your own that could get you. We have a voltage regulator, a 7805 voltage regulator that we need to put in. And he's going to go right here. He's marked as U4. He's going to go in like this. He's going to bend over. Now you'll see if you look closely, the legs get thicker, so you can only go down so far. So that's where she wants to stop, and that's where she wants to bend over. And you start the bend like that. What I do is raise it up just a little bit off of that, and you can then bend it down flat. So I just work her a little bit at a time. I don't know if you can see what I'm doing here, until I get her lay flat. That way I don't end up with a sharp kink in it. Now I'm going to bend it a little more up. It's not going to want to stay in for me. So this is another one of these ones where it's helpful to take a little solder and tack her in with one. Now these are bigger packages, and they're designed to take heat away because they heat up. So it takes a little more to get that on there. So now let's solder these two and then resolder that one. Get where I can get to her better. If you get on something and it's taking too long to get hot, stop, back away, and let it cool off. Now, you have to be logical about that. You have to think about it. For example, with this is a big old TO220 with a big heat, basically a giant heat sink built into it. So it's going to suck heat away. It's going to take a little longer to solder than, say, a resistor or something. So it's reasonable for it to take a little bit longer, and you don't need to panic over it. But if you were doing something small and delicate, and it was doing this, like a small IC or transistor or something, then you'd want to say, wait a minute. Why am I taking so much time to do this? I don't want to cook this part. So we've got that in. What are we missing? We've got a crystal to get in. We've got a bunch of capacitors to put in. So I'm going to go ahead and drop the crystal in. Crystal's X1 right here. Now this crystal doesn't care which way it goes in. We have a T1. He's right here. Okay. So we got one side with 3 pin and one side with 2 pin, so it only goes in one way. We've got B1 to put in, which is this rascal. My question is, which way does it go? If it gives me any hints at all. Okay, it's a common mode coal, so it probably doesn't matter. There is, let me take a good look here. No markings, no coloring. So I'm going to say it doesn't matter. It looks on the schematic, on the silk screen of the board, it looks like it's showing the same M on both sides. If it was a transformer, it would be different, but it's a common mode choke, so it probably would have no matter. So we've got that. Let's solder him in. Okay, he's in. Let's go ahead and throw our power jack in. Actually, let's go ahead and do all our capacitors, our electrolytic capacitors now. Now remember, electrolytics, unlike the ceramics I put in earlier, they all have polarity. If you look closely, you'll see that there's a stripe with a minus on this side and nothing on this side. So we've got to watch our polarity on these. So if you notice, there's a little plus on this side. It also has the square pad. Those are both indicators of the positive side on a capacitor. I'm going to speed through this. I'm going to go ahead and pop all these in and solder them in, and I'll be back. We got the electrolytic capacitors in. Now we just have some larger components to put on to get the little display board done and put on. I'm going to take a quick break here just to go refill my drink and take a moment. I'll come back in a few minutes, pick back up, and we'll go from here. So see you in a couple minutes. All right, I'm back. We're ready to get back to work. Let's see what we're going to put in now. Put our power jack in here. Okay. And I would say let's go ahead and throw in our audio jack over here. See what else we got to put in. We've got our speaker. See what else we got to put on here. We've got a push button that needs to go in here. It's got a couple bent prongs. We got to straighten out here. Okay, we got that. What else goes on here? We've got our BNC connector for our antenna here. Now it comes down to this little board. And it looks like it's a pin straightened out here. She's showing it on the silk screen is going in like this. Getting these pins in might be a challenge. They got kind of bent, so. There we go. Okay, so she's in there. You got the LED. It goes here. And this guy only goes in this way. Now, I'm going to use my foam to try to hold this guy in while I get him tacked in with one of the pins for the LED. Alrighty, let's turn this LED off a little. Now, this is going to be, go here, connect that down to the board. It's pretty short that way, so I think it's definitely probably goes in that way. So, see if we can get this soldered in. All right, put our little display board on. Get him soldered in. And now all we have is some hardware. I assume is if you want to put this in a case, and the chips. And so, probably being overcautious, but I'm going to throw on my static strap just to make sure before I start handling these chips. See if we can get these chips in now. Making sure my little notch in my chip is pointed towards the notch in the socket so that pin 1 is the right direction. Now, that was easy enough. We got to make sure we get the right chip in the right place. So, let's see here. U2 is which one? Okay, U2 is the 7613. So it's on the 7613, this chip right here. Make sure we get him in U2. So that only leaves one chip, so he's got to go in here. We got a couple inductors to put in that I've skipped over, and then we're done. This is built. What I will need to do then is rig up power, an antenna, speaker. We will start testing and troubleshooting if it doesn't work, which I don't know. Pretty cheap built thing with thrown together. Who knows where they got the parts off the floor of a plant for all we know. But we will find out. So let's look at the last items we've got to get in that I've left off, and that is the inductors. And they are here. They're listed here. L1 and L4 is 100. L1 and L4, let's find them. There's L4 right there. So okay, L4 right here. L1 right here. Okay, I see right by the crystal. Now, L2 is the 820. It's this one. Last but not least, L3 is a 4.7 microhenry, and he is right here. So let's get those four soldered up, and we will have a radio built. But that's it, folks. This is our little radio. And so in our next video, I'll get everything rigged up to test this thing. We'll fire it up. We'll do a little testing, and we'll see how we did. And it could turn into a testing and troubleshooting too. So that's another reason I want to make sure that we don't try to do all this in this one video. It would have been too much. I'll see you in the next video. We'll give this thing a try. We'll see if this thing even works, and if it does, just how well does it work. So, hey, thanks for hanging in. I know this was a long one, but it was a build. Appreciate likes, appreciate subscriptions more than anything. Really helps me a lot, guys. If you haven't subscribed, sure would be a big benefit to me, and I would appreciate it greatly. So I hope to catch you in the next video.